I am going to explain about ultrasonic sensor, how to interface ultrasonic sensor with Arduino Uno. So ultrasonic sensor has basically 4 pins. So this pin is a ground, so we are connected with the blue one and we connected to the ground, and this yellow is for VCC, so we are providing VCC to the ultrasonic sensor. Now this blue pin will indicate trigger and this red one is a echo. So these two pins are connected with pin number 9 and 10. So trigger pulse is connected with 9 and echo we are getting from 10. So now before interfacing with the ultrasonic, we need to be sure that these connections are made from the ground only, right? And one more thing is, when you are interfacing with ultrasonic sensor, at that time you need to provide some refresh time in the programming, so we will see it later. Now what we are doing actually here is, here we are actually measuring a distance, and from that distance we are going to glow either a red LED or green LED means you can go ahead, or red LED means you need to stop. So now to understand the working of this circuit, we need to look at the programming sequence. So this is the programming sequence. We start with we have declared trigger as a pin number 9 and echo as a 10, as we have discussed. Then this go ahead LED, that means a green LED is connected on 14 number pin and red LED is connected on 15 number pin. We have declared a duration, so we are going to measure a duration of the echo pulse. So we have declared a duration as a long integer, and we also declared a distance as a float. By declaring a float, you have a accuracy on up to 2 decimal places. We also declare one constant float, that is a safe distance. So if you need to change the safe distance, you can change this just from here. Right now I have put it as a 10 centimeter. Okay, so let's have a main setup file. So this setup file will give you the pin mode functions. So pin mode function is a trigger, so we have declared as a output because we are going to give pulses. Then digital write, so we are making it low as always. Pin mode echo input, so we are reading echo pulses, so that's why it's a input. Go ahead LED and stop LED both are output, and we are also going to use a serial communication, so serial dot begin and 600. Now in a loop we have used these pulses. Here I have commented on delay 100 and delay microseconds too. Those are unnecessary parts, so please ignore it. Now we start with digital light trigger high, so we make it high and then we are providing delay microseconds 12. Here actually, as per the theory, we need to provide only 10 microsecond pulse, but I am going to provide a 12 because of there may be an inaccuracy of 2 to 3 microseconds in Arduino Uno. So I am going to apply 12 microsecond pulse. Digital write trigger low, so after making it high for 12 microseconds, we will make it low, and after make it low, just we are now going to get a duration from the echo pulse. So duration equals to pulse in. This function will read the duration time of the echo pulse, so echo pulse, and we are making it high. Now for the duration for distance calculation, we have put here one condition, that is a duration is, if less than duration is a 200 into 2 divided by 0.034. That is a distance we can calculate from the range of ultrasonic sensor. So distance equals to float. So actually duration is a long type, so we need to convert into float. So float duration into 0.034 by 2, so that will give you a distance in centimeter. Now we are going to print it, serial dot print, then and so these are the sequence. Now here is the thing. See, if the distance is less or equal safe distance, that means we have declared a safe distance as a 10 centimeter. So if it is less than or equal to 10 and your distance one more important is a distance is greater than 0. This is why required, because when there is no object in bound, so it will give you simply 0. So it may happen that you are giving 0 and you are considering as this object is very close, but it's not so. So that's why we are ignoring 0 distance, so greater than 0 is as always. So digital write, at that time we are going to digital write stop quality high and go ahead low. So if it is a set distance lower than the set distance, then we need to stop, right? Then after that we have again the second condition, and that is if your safe distance is you are ahead of the first safe distance, then and your distance is also greater than 0, at that time we can move ahead. So that's why go ahead LED will glow. And now for the refreshing time, I have used here only 1 second time. You can put even 100 milliseconds, but that is not necessary right now. So for these applications you can put 1 second or let's say 500 millisecond and so on. Minimum time that can be refreshed is at 29 milliseconds. So never put the 29 millisecond there, because it will definitely will affect on your operation. So from these now let's have a look at output side. So serial monitor, let's look at the output. So right now it is providing 76 centimeter around, right? And you can see here the green LED is on, right? And the distance you can see from this measure that is so you can see over here, see, so around is 74 to 76 centimeter. Now let's put one object. So see, now so at the 35 centimeter I put one object, and see the output, right? So and at that time still LED is on. And let's just make it to see. So this is how it works. So now distance is a 5.51 still, okay. So as the distance is moving further, and green LED will on. So let's make it to the perfect 10. So this time it's measuring 10.01. so see, so 10.01 and 9.89. Right. So that is the worst case, because what is happening over here is the object is slightly inclined. Now let's make it linear and see. So now